Hello, I'm Joseph. I use Raylib with PHP, and one thing I wanted to know is it's based on OpenGL, and OpenGL for macOS has been deprecated for a while now, and they recommend to use Metal. Raylib has kind of looked at this and eyeballed maybe potential of going Vulkan at some point, if it ever does become a bigger issue, and then have like an MK or Molten Vulkan kind of crossover situation where I think it's like just called MK Vulkan, where it can take Vulkan code and translate it to Metal, but there is that translation layer, so you're not getting like raw performance out of Metal, but you're still getting better performance you would have if just using OpenGL. And so here I have a little benchmark. I just was inspired from someone else on Reddit. They had done a Windows version of this, and so I did a Mac version of this. Um, and I just have 16 gigs. It's an M1 processor, not an M1 Pro or anything else. And you can see that the dynamic languages are GPU bound, so they can't go beyond 100,000. To be honest, it kind of gets stuck. And the CPU has headroom to do more. It's just the GPU can't do that. And so it's stuck at 85 frames for C, Zig, Rust, Go, and C Sharp. And just to give you some context of what that means, if I minimize this one and play this here, the bunny benchmark is just rendering a bunch of bunnies on the screen and doing rendering up to 100,000 of them. At least that was the benchmark that it was showing there. Um, and this is all running through OpenGL, which gives really good performance. And the reason why it gives really good performance, because if you've ever tried to do this in regular OpenGL and render 100,000 bunnies or just sprites on the screen, once you get beyond like 4,000, it's going to get really slow very fast. And it's because Raylib implements batch rendering, or more known as instance rendering, where you have a single quad that you specify, whether it be like a 1 by 1 quad, and then you move it around, but you send all of the data at once to the shader, and the shader will handle that rather than sending it to the shader individually 100,000 times. You set up these kind of limits to kind of split them up into batches, and you send these batches to your shader there. So you can see that even in dynamic languages, you can get some really good performance. In all the dynamic languages, the bottleneck becomes the CPU and not the GPU. It just can't do the calculation of that 100,000 fast enough for every single individual sprite. NIM was one that should have been higher. I had a couple instances where I was seeing 85, but it was just like random. I tried different releases of NIM in terms of like different flags you can put for better performance, whether you're doing no boundary checking and stuff like that. But it didn't really matter, didn't add any better performance out of that. And then for hacks, while it is a compiled language, it's more like JavaScript or TypeScript. It's really good. It has actually some other good game frameworks on there. It's just it's not very optimal in terms of a compiled language, but it's far better than any of these dynamic languages out there, and something I really do recommend. The only catch is that specifically on the M1 Mac Mini, it didn't compile as it should have, because it's trying to reference the latest versions of Raylib and it can't work with them. I submitted some pull requests to them. They may be handling it this weekend. I don't know. The same thing with Lua as well. Lua should have been a lot higher on this list, to be honest, because it is Lua JIT, but it doesn't. It's not working as it should. And the reason why I say that is because Love 2D, which is another 2D or another game framework, but it's specifically for 2D games in Lua, runs insanely fast for a dynamic language. Actually runs faster than Hacks. It was running about 48, 49 frames per second and about 200 plus, more in line basically memory usage of like what PHP was using. But it gives you a lot of great performance, a lot of headroom to do rendering as you need to. And I don't think they do native metal rendering either. It's just regular OpenGL as well. And then just a note for Python, I'm using the FFI implementation, not C types. So that's just really slow. It's doing a bunch of calls and overhead calls to get to the C layer through Python, which isn't really ideal. And then I did try other game frameworks. So Pygame was one. The reason why I tried Pygame because I thought I swore I read somewhere that there was a experimental flag that they recently added within the last year that you can actually toggle and switch hardware acceleration mode on through OpenGL. I can't seem to find that. There are other libraries with Pygame that you can couple together to get that hardware acceleration. I just didn't want to try that hard. I did try sprite grouping. That didn't really have any improvement. It's just really slow because Pygame out of the box is software rendering. So all the rendering is done on the CPU and not on the GPU. Dragon Toolkit was something I bought a while ago, and it is impressive for what it cannot do. When meaning that it's doing 100,000 sprites and is also doing 100,000 draw calls. Just for reference, all of these dynamic languages that are getting these high frame rates or higher frame rates, they're only doing about 12 draw calls, and that's because it's doing that batched rendering. Dragon Ruby Game Toolkit does not have batch rendering. It doesn't have that. I tried render targets to maybe see if that was going to speed it up. It does not. You're also locked at 1280 by 720 at 60 frames a second. So I can't even get it to be benchmark like it would be for like Pygame or any other game toolkit out there. Then I also thought about, okay, how fast could I go if I was using like native metal rendering? What's the threshold I can go highest to? And so I did run into Bevy. Bevy is a Rust game engine for 2D and 3D games. I really liked it, but um, it ran into a problem, and I'll go ahead and show you that here. That the frame rate is highly unstable, and I need to fix the mouse stuff here. But it can't get. I'm not going to bother showing it, but it can't get to um, the high performance that it needs to, even though it's using metal. And the reason why is because Bevy also does not support batch rendering or instance rendering. There is some stuff on the pipeline for it, but it's been like I think over 2 years now, and they're still working on getting it inside of Bevy. But overall, I still really liked it. It's just, I wish it did have batch rendering because if you're doing any type of like bullet hell or like a vampire type of thing where you just have a ton of sprites coming at you on the screen or a bunch of animation effects in 2D, or you're doing like these sim games that have a lot of individual sprites moving across the screen, you really do want instanced or batch rendering implemented. Unfortunately, Bevy didn't have it. So what I did next was I jumped down into BGFX. Now, just for some context, the last time I've touched like raw graphic stuff was like 12 years ago, and that was with OpenGL. So, yeah, it's been a very long time since I've actually bothered with OpenGL, and I wanted to use Metal. So BGFX is a game, not a game. It's just a rendering library. So if you want to load textures, you want to play sounds, it doesn't have any of that stuff. You want to do animations, doesn't have it. But it gives you enough room. And this is the same thing that's used for Minecraft Bedrock Edition. It's a very low level type of thing, but not as low level if I was directly into Metal. Now, I did try writing in Metal with Swift. I was just having a lot of issues understanding the shader language for Metal itself over something like the shader language for OpenGL or Vulkan and stuff like that, because there's a lot more documentation on that than there is specifically for Metal. But it gives me an opportunity to, at some point, if I wanted to do this, move to iOS, make a game for iOS, and not have to worry about what's going to happen with Raylib down the line. Now, Raylib does have a plan for Raylib 5.0, and they are looking at SDL, and SDL would help them get to iOS because the windowing framework part of this is based on GLFW, which is limited on the number of platforms it can run on versus something like SDL. So if Raylib does manage to move the framework to SDL would be really nice. But until then, it's probably going to be a year plus out before that happens. But yeah, so yeah, BGFX, and then for windowing, I chose SDL2 because SDL does have the ability to give access to BGFX a metal layer to render on top of. So all that equates to me bashing my head into even just getting a window to show, much less a texture to show on the screen. And as I was doing this, I had to learn a lot about the vertex shader language that they implement. So BGFX, while it says GLSL, is not an OpenGL shader language. It is like that, but they rename a couple things, and they also have a bunch of code behind this to translate between each of the different, like DirectX and Vulkan and Metal and OpenGL and OpenGL ES. And so you have a vertex shader and you also have a fragment shader. Vertex shader is just positioning the different vertices on the screen. Normally, like you would use this to like create a wave effect. You would have your mesh with all these different points and you throw it through the vertex shader. But in the terms of instancing, what you do is you have a quad that you have that is the same position every single time. So if I have you go down a little bit here. So I have my vertices and my indices of my simple quad, which is a flat plane. I toss it into my vertex shader, and based on the instance that I have of all these different data points, I can do scale, rotation, and then the actual position that it should be at when it's translated. So I can do all this stuff. I can also pass in the color. So if I need to colorize the sprites, I can do that as well. Um, but yeah, it's it was a lot of work, a lot of banging my head. And more specifically, this is all written in C, which is even a bigger disadvantage because a lot of implementations that use BGFX does not use the C variant. So a lot of the things that I was finding wasn't working. And then on top of that, the shader language, BGFX shader language, is more niche. People tend to write the OpenGL plus the Vulkan one plus the DirectX version. They would rather go that work making these different shaders than work inside of the BGFX shader language itself and do that. So um, yeah, I just wanted to stick with it, and it was a lot of pain, but the payoff was quite well. So this is the same thing, the same Benny, but this is running using C, BGFX, and SDL2. And then you can see down here as I try to get close to 100,000. So we have 95 and 100,000. So 100,000, 103,000. If I go to here, you'll see that my GPU time or my GPU percentage is only at 40%. And by the way, I'm running this in debug mode. Basically, my threshold went from 100,000 limit to 300,000. I can render up to a 300,000. And at that point, I actually become CPU bound. Now, the M1 processor has an insanely fast single core process. If I was to try to even go faster, I would have to multi-thread this, synchronize the threads with either Mutex or Share and go, do a whole bunch of stuff. But this gives me just a ton of room to work with and a very interesting experience to work with as well. And yeah, it's nice. I really like Bevy, but having to write all this stuff by hand, while very painful and crashing a lot and finding a couple things. By the way, like I found out I can apparently do this here, this main file that I was working on. I just gave up and started all over again. I created an infinite loop for the compiler to never compile this file, apparently. I don't know how I did that, but I did. And yeah, so I also tried a single instance without batch rendering. I got to like 4,000 draw calls and it would just constantly crash. And I found out it's a bug and BGFX with its thread synchronization because SDL and BGFX metal rendering runs in separate threads and they need to synchronize. But once you get to about 4,000 calls, it just crashes with a mem copy issue. If you do it in release mode, not a problem. You do it in debug mode, it will crash. So I was getting really frustrated with that. I also ran into a limitation where I needed my dynamic vertex buffer to be bigger, and it just wasn't. There's no documentation on how to do that. Sorry. But yeah, so that's just been my little journey. Now, why would I do bother with any of this? Why would I even think about this when I still have my bindings to work with for PHP? Well, Raylib really sucks for implementing in a dynamic language. Many of these dynamic languages, like Node.js, like Ruby and Python and Lua, they have a subset of Raylib that they will implement. Mostly the subset is limited to 2D and audio work. 3D is kind of out of the picture. And it's not like it couldn't do it, it's the amount of work that you would have to do to get it to work. And so, like 3 days ago of this recording, I actually submitted another update to get mesh with load mesh from no, load model from mesh, which was a ton of work to figure out what the hell was going on. But basically, you could technically do 3D with PHP, Raylib PHP, and you get the entire substructures all given to you as regular PHP arrays. So you can go down the stack, which is why the memory usage is quite higher than it would be on any of these other dynamic languages. It's because it's going down the entire substructure, building out everything prematurely. So when you need to access it, you can. If you need to add in stuff, you can. I still got some more work to do. So if you were to like append another material, that doesn't technically work. These materials are built on a single thing. So for example, you can only have one material for a model, but Raylib gives you the opportunity to have multiple materials, but you can literally only have one. I don't know why they limit it to one, but they give you the array, maybe for something down the line. And then inside the material, you can have multiple textures. So you have a material map, and that map has up to 12 different textures based off diffuse, non-diffuse, or maybe a normal map. You can do all those things. So trying to get this all implemented, it's just been a huge pain in the ass. And the main thing is because most of the substructures, or even just the structures in general for Raylib, are all put on the stack. So I have to go take that, copy it somewhere else, put it on the heap instead for global access, and push this into a hash map so that when I need to give you an object, a PHP object that wraps around a Raylib structure, I'm giving you a pointer to that structure rather than have it live and die within that PHP object. I thought originally that was a good idea, but then things get garbage collected and deleted, and you try to access it, it'll segment fault or crash, and it's just not really ideal to give you that raw object inside the PHP object and ship that around and have PHP figure that out. Because, by the way, garbage collection doesn't always work out that great, specifically with reference counting. Every time, like even right now, I'm sure there are memory leaks happening with Raylib PHP that I have not yet gotten to. And so it would be nice to be able to isolate only 2D game engine for PHP, but have an extremely high performant variant and do something like Love 2D where you're not putting your whole while loop inside of PHP. Rather, you have these callback functions in your PHP game that you just do like a draw or a load or a setup or something like that, and you do all your code in that, and that code gets called, 100 times for 100 frames, but it's not you controlling all that within your PHP code. And that would be a lot better because then you're running this runtime inside of whatever else. And I've been working on seeing how that would play out. I need to open up another project or my Raylib project here. Let's do this window. um, how to bundle it together then, because it makes bundling a little bit easier too. And I was looking at or working on with Rust to pull in the runtime. Why is this? Oh, that's my build script. Pull in my runtime, so actually embed PHP into Rust, which gives me a lot of opportunities to work with some higher level stuff. So if I need to multi-thread the game aspects of physics and network and your game logic world stuff, I can split these all up, have the tooling of Rust, its ability to handle um, multi-threaded applications with specific substructures for collections that I can pass around and work with to give you guys some opportunity in PHP to have like a really high performant thing. Because PHP, like you see when you have PHP with Jet, it is quite high performance. Um, it would be nice to be able to further that along and not have to like kind of get stuck into PHP by itself and then figuring out how to deploy that. So I've been working with a bunch of different things of trying to figure out where my limits are, maybe what I can do, and not be specifically bound to Raylib itself. Because while I do like Raylib and it is really good for a very simple game, once you get into more complicated stuff where you need to have multi-threaded things, it gets really hard very fast. And while PHP does have the ability to do multi-threading, it's kind of like a share nothing message around type of thing, which is fine as well. But when you want to build certain 2D games, even then, you may run into some performance issues. And then the bigger question is, how the hell do you even get any of this to work on the web? How do you ship it with iOS? Because iOS doesn't have the ability to do the PHP runtime with it. And at least from when I last checked, you can do the JavaScript runtime that it ships with, and you can ship JavaScript code that runs on the fly. But if you want to put in like a PHP embedded engine, that's not possible. So I would have to compile this to WASM. push WASM into its JavaScript runtime core thing, and and do all these like weird stuff where you're getting all these performance hits, but it'll still be better than not having it run at all on iOS. It's just things that I'm working on, looking at, and potentially thinking about, because BGFX does have even more capabilities to run in more places with SDL as well, and having kind of just like a no-brainer experience, at least for 2D games. Like it's nice to be able to think about building something in 3D with PHP, but the more I think about that, the more it just hurts my brain on where how I would make that perform in every single use case that's out there, and specifically going onto the web with WebGL or with WASM as well, shipping all these things out. It's just, I don't know, it just gets really convoluted on how performance will react, and it doesn't really make sense on the web, but it maybe makes sense for maybe an Android or an iOS app. I don't know, just a whole bunch of things on my part to think about.